Okay, so we are going to think about a new example. So in the previous video, we learned about transformation of random variable and calculating the expectation of the transformed random variable. Uh, and the key idea is if we have a linear relationship between the original random variable and the new random variable, then we can calculate the expected value of the new random variable very easily, right? Directly from the relationship and the expectation of the original random variable. So, continuation of that idea, we are going to study a new example. So, by the way, our family will be going to the Disney World this Christmas like vacation. So, yeah. So, I made this example many years ago when my son was really young. He's now 8 years old. So it's a little bit too late to go to the Disney World, but anyhow, so imagine that you have a small kid and your family would like to go to the Disney World before it's too late. If your kid is grown up and may not be able to fully enjoy the Disney World. So I'll think about what is the probability of going to the Disney World next year in 2025, for example. And this is my estimated probability. So it is possible that like with 50%, I think I'm not going. But 40%, yeah, we may go to the Disney World if we really enjoy this year. Then we may decide to go again next year once. And with a very small probability of like 10%, if we were extremely satisfied and if we are lucky, then we may be able to go twice next year, like in summer and winter, for example. Anyhow, so this is a random variable, like the number of trips we will go to the Disney World in 2025, and we'd like to calculate the expected value of that, right? So I will leave it to you. Just try this, and I will turn to the next page, assuming that you have done this by yourself. Okay, so the number of the expected number of our trip to the Disney World is zero point 0.6. Okay, then uh, actually what I'm interested in is not the number of trips. More important is the cost. How much it costs. So to simplify the story, I will just assume that the cost is $1,000, right? Actually, I booked a ticket like a month ago. It was like $5,000 for admission, and hotel and flights, including everything. I have to expect like 5,000 plus additional expenditure on site. Anyhow, so 1,000 is absurdly unrealistic number, but keep it simple. Keep the number simple, like so. We'll assume 1,000. Anyhow, so the variable I'm actually interested in is the total spending on Disney World trips, right? Like it could be zero if I don't go there. Maybe it could be twice, like if I go twice. So anyhow, so simple, calculate the expected spending. Assuming that when you go there, if I go to the Disney World once, it will cost me $1,000. So calculate expected cost. Okay, so there are two different ways. First, you may make a new probability distribution table for y, the new random variable. That is possible. So, that is one thing. And second possible way is to use the formula, the linear relationship. Like by verifying that the relationship is linear, then you can simplify the algebra because we already calculated the average number of trips, right? So let's check the second method first, right? The relationship is linear because for each trip you spend $1,000, right? So It is linear. Simply just multiply 1000 to x, original variable x, right? So because we verified, we confirmed the relationship is linear, then we may directly just plug in the expected value of x here to obtain the expected value of y. So 1000 times it is zero point 0.6. So then expected spending is $600. That is the expected spending from going to the Disney World, right? $600. This is like easier method, express method, but if you are uncertain if this is linear or not, don't take the risk. Just do this, right? Change change numbers from 012 to 0,000 to 1,000 because it's y x is number of trips, y is dollar, right? Spending. So you get new numbers, but the probabilities do not change. Probabilities are the same. Then multiply the outcome to the probability to obtain the probability weighted outcomes. They are like this, right? 0 times zero point 0.5, 1,000 times zero point 0.4, 2,000 times zero point 0.1. So you get three numbers, probability weighted, and sum them, then you get 600. Should be the same, right? Yeah, right? So anyhow, the answer, either way, should be the same. But as I said, this is safer because this method, this full transformation method is true all the time. Anytime, like no matter what, the relationship between x and y is, this is true. But this is true only when x and y is linear. So it's up to you what method you use. Or you may use one method as a double check the answer. Now I'm going to change the scenario a little bit. So, okay, I'm budgeting the trip, but I found a discounted ticket on eBay or like somewhere. Uh, so it is $700. I have to buy this ticket right now. But the problem is, like, you are paying $700 now to buy the ticket, but if you do not go to the Disney World, then simply suppose that you lose it, right? You lose $700 because you did not use it. And in case if you go twice, then the second trip is full price, $100. Okay? So I will label the total spending when you buy this discount ticket from eBay as Z. Z is a new random variable, right, in different scenario. Okay? So then you get Z like this, right? So when you, even if you don't travel, still you already spent $700. So you wasted $700. And if you go once, then your $700 discounted ticket is good. That's your spending. But if you go twice, the second trip costs you $1,000, the full price, right? So the total spending would be 1,700. That is this scenario, right? Then recalculate the expected value of Z. Okay, the idea is the same, but the transformation is more tricky. Do it by yourself. Pause the video. Okay, let me show you how to do it. First of all, it is easy because I already gave you the probability distribution table for Z. So what you need to do is just multiply line by line and make another column and sum out the products, right? That is always possible. And then if you do so, you will get this. Excuse me, later I will show that in the next page. The problem is the easier method does not work in this case because x and y are not linear. The relationship is not linear. That means when x increases from 0 to 1, z does not change. The slope is 0. But when x increases from 1 to 2, the slope is 1,000, right? So it goes like this. So there is a kink. Slope is not the same, so it means it's not linear. So this is an easy way to check if the function is linear or not. For each increment in x, the change in the outcome must be the same. The slope must be the same for the relationship to be linear, but not the case here. So expected value of x does not help. You have to recalculate everything from this table, right? So the shortcut is not available. You have to multiply line by line and do this method. So the new column, third column, contains probability weighted outcomes, and you get expected value of 800. So now the expected spending is $800. So then what you can do is you can compare this number to the previous expected spending, 600. So that means 600. Why is when you do not buy the eBay discounted ticket. So if you do not take the offer, eBay discount, then your expected spending, your spending will be lower on average than this. So it helps you make the decision. Your correct decision based on the average is not buying the discounted ticket, right? Because, and economically, because there is a 50% chance you lose that $700. So the discount is not worth, right? So if you change the probability or the how much it is discounted, it could be reasonable. The discount, it may be rational to buy the discounted ticket, but not in our example. Okay, so then I will show you another possibility or another option. Suppose that there is an annual membership, like to a credit card or to the Disney World. I like just imagine a membership. You have to join the membership right now, right? Uh, by paying $600 upfront. It is annual membership fee. But once you join the membership, you get a discounted ticket for $500 throughout the year, right? So if you imagine this deal, it goes like this. Even if you do not travel, you already paid annual membership fee, $600. That is your spending. But if you travel once, then your spending is the membership fee, $600, plus the ticket for one trip, right? $500. So total 1,000 and 1,100 is your total spending. But if you travel twice, then your spending is 600 membership fee plus 500 plus 500. First travel, second travel. So total is $1,600. So now W is the new random variable. In this case, if you join the annual membership now, then W is the your new random variable under that scenario. So then try to calculate expected W, because you have to decide whether to join the annual membership now or not. Okay, do it. And especially in this case, what's important here is you need to check if the relationship is linear or not. If you believe that they are linear, then this is really simple. But if you think it's not linear, if you are uncertain, then just use the probability weighted outcome. Okay. Okay. Let me show you the answer. In this case, the relationship is linear. You may write their relationship like this. As I said, you multiply 500 to the original random variable and add 600 to that random variable. So, like this means you pay $600 no matter what X is, right? Even if you don't travel or even if you travel twice, you pay $600. But for each trip, you have to additionally pay 500, right? That is the increment. When X increases by 1, then your spending increased by only $500. But 600 is fixed cost. Okay. So if you now you verified the relationship is linear, it follows the same like the format, right? A times x plus b. A is 500, b is 600, and then plug in the expected value of x into this function. So here, plug in zero point 0.6 here, then you calculate the simple linear function, then you get 900. Again, it is greater than our previous expected value 600. So it's obvious because expected spending is 600, so you don't need to pay $600 as a membership fee. It's too much. $600 is already so expected value cannot be lower than $600. So the membership fee is not worth. It's not economical, right? So again, so I wanted to show you two things. Statistically, you have to tell it whether it is linear or not. And the idea is when x increases by a certain unit, certain increment, y should increase the same amount, like equally. The increment in y should be equal. That's how you tell linear or not. And second, expectation is really useful to make a decision. So you are, as a rational consumer, you have like in economics, we usually assume that a rational consumer maximizes their expected utility. Exactly, this is what we are doing. We are minimizing the expected spending. So this is very important in economics. So by the way, we took the shortcut to calculate the expected value of W. But even if you use the probability distribution table, same thing, like weighted outcomes, calculate the weighted outcomes, and still you are going to get the same $900 as it should be. Okay. Okay. So far, we learned what is the mean, the definition of the mean, and how to calculate the mean. And then on top of that, we learned interesting examples of transformation of random variable. Basically, the random variable is a numerical description of the outcome. So changing the number does not change the underlying probability, but it changes how to calculate the average. There are two methods depending on whether the relationship is linear or not. So I hope it helps, and you are going to practice this in the quiz. In the next video, I will change the gear and will discuss some problems and alternatives of the average. Okay, see you there. Thank you for watching.